So kita akan terus sambung daripada dari yang mana kita sudah berhenti dahulu. So we'll stop last time at topic 2.3. I think it was topic 2.3, free fall motion. And now we'll be going into topic 2.4 and topic 2.5. So inertia and momentum. So just sebagai pengetahuan kamu sajalah. So these two topics, inertia and momentum, these two things are actually very closely related to each other, which is why I decided to cover both of it in just one lesson. If you can understand inertia, then you can understand the idea of momentum. Okay, so for those of you who just came in, make sure that you pin my screen. Make sure you pin my screen so that you can see all the notes clearly. Okay, so inertia and momentum. So what is inertia? What is the definition of inertia? Inertia is the tendency of an object to remain at, or, if moving, to continue its motion in a straight line at uniform velocity. So two things. Inertia is the tendency of a motion to remain at, or if moving. So if something is not moving, then the law of inertia states that it has a tendency or it doesn't want to move. Or if it's moving, then the concept of inertia says that something that is moving has a tendency to keep moving. So what is this in simple terms? Saya mau kasih bagi penerangan yang paling simple lah. Kalau ada bola sepak, kamu nampak di tanah. Kalau ada bola sepak yang sedang duduk di tanah, bola sepak itu tidak akan bergerak sendiri. I know that seems obvious, but that is a law of physics. Itu bola sepak yang berada di tanah itu, dia tidak akan bergerak sendiri kecuali ada sesuatu yang dilakukan untuk menggerakkan bola sepak itu. So this is what we call as inertia. Bola itu mempunyai inertia. The ball has inertia, which means the ball does not want to move unless you make it move. Nah, pada masa yang sama, kalau kamu tendang bola, sekarang bola sedang bergerak. Now the ball is moving in a straight line. The ball is not going to stop until something forces it to stop. Bola itu tidak akan berhenti sehingga bola itu dipaksa untuk berhenti. So this is the idea of inertia. This is what inertia is. If something is not yet moving, it will not move unless you force it to move. If something is already moving, it will not stop unless you force it to stop. This is also called Newton's first law of motion. So we go back to old friend, Mr. Newton, Isaac Newton. The guy who is making all our lives more difficult in physics. Well, not really. It's very useful. But all these things exist because of what Isaac Newton did. So, this is how Newton wrote the law. An object will remain at rest or move at uniform velocity unless acted upon by an external force. So sama seperti yang saya sudah jelaskan tadi lah. Okay? If I simplify it, here's a simplified version. A stationary object will not move unless something makes it move. A moving object will not stop unless something makes it stop. I know some of you are thinking, that is so simple, like mind blown, like everyone knows that. Simple logic. But the thing is, we never think about this. Ya. Kita tidak pernah terfikir kenapa benda yang kita letak di tanah, kenapa dia tidak bergerak. We never think about it, but the thing is, even though the object is not moving, let's say you put a ball on the ground and it's not moving, even though it's not moving, the reason why it's not moving is because there is a force that is preventing it from not moving. And if you kick something and it slows down, or if you move something and like you kick a ball and it starts to get slower, the ball will only slow down because there is a force, there is something that is making it slow down. So anything that moves, there's a reason for that. There's something that makes it move. Anything that stops, there is a reason why it stops. That's basically an explanation of Newton's first law of motion. So why is it so important? It's very important when you're thinking about buildings, when you're thinking about vehicles, anything that has to move, anything that has to stop, we'll be using Newton's first law of motion. Alright, so inertia. Relationship between inertia and mass. So like I said just now, inertia is the tendency of an object to keep moving when it's moving and to keep still when it's still. Now, Logic 101. An object with bigger mass is more difficult to set in motion. Objek yang lebih banyak jisim dia lebih susah untuk membuat dia bergerak. Okay? Logic 101. Something that's heavy is hard to move. It's much harder to push a car than it is to push an empty box, for example. Right? And at the same time, it's also much more difficult to stop a moving car compared to stopping an empty box. Why? Because a car has more mass, has bigger mass. Any object has bigger mass is harder to stop and harder to make it to move. Therefore, we can conclude that the larger the mass of an object, the larger the inertia of the object. Inertia is basically how stubborn something is. If I want to give another definition, inertia is how stubborn an object is. When I say stubborn, I mean if it's still, it doesn't want to move. There's a lot of inertia. It's very stubborn. It doesn't want to move unless you really force it to. Or if it's already moving, it doesn't want to stop. It's very stubborn. So you have to force it to stop. So an object that's heavy, like a car, has a lot of inertia. And so it requires a lot of force to make it stop. So like a car, you really need to brake. You need to have good brakes and a lot of force to make a car stop. But if it's just an empty box or like just a very light football, it's easier to stop because it has less mass and less inertia. So what does inertia look like in daily life? All right. So inertia in daily life. So there are many examples of inertia that we see every day. Example, when you ride a car. When you're in a car, all of a sudden the car brakes. What happens? What happens when you're in the car and the car suddenly brakes? What happens to you? You tend to move forward. Kan? Kau mau tepi ke depan. Kenapa itu berlaku? Because your body has inertia. Okay? Walaupun kereta sudah berhenti bergerak, tetapi badan kamu masih ada inertia, dia masih ada kecenderungan, masih ada keinginan untuk terus ke depan. It has that tendency, it has that inertia to keep moving forward. Because you need to force yourself to stop. So how do you force yourself to stop? By using a seat belt, right? So the car stops, but you don't want to stop yet. So the inertia makes you keep on going forward until the seatbelt stops you. That's why the seatbelt is so important. Itu sebabnya kenapa kita disuruh untuk mengelakkan kemalangan dengan memakai seatbelt. The problem is not that. The problem is when a car stops and you're not wearing a seatbelt, you will not stop, and so you'll fly out of the car or you'll go through the window or something like that. So inertia is a problem when it comes to safety when driving. What else? What else is an example of inertia? Oh, the opposite. If you're sitting in a car and all of a sudden you press the gas. Okay, all of a sudden you go from 0 to 60 kilometers in 3 seconds. What happens? What happens to your body? Then your body starts to go backwards, right? Because your body is still, and all of a sudden the car moves forward, but your body doesn't want to move yet. It still wants to stay still in the same position, and so you tend to go backward until the chair behind you stops you, and then you're forced to move forward. So that's inertia. Another example, there's the very common party trick. Kan? Ada meja yang ada banyak piring di atas, tapi ada kain dia dan kamu buka kain. So sometimes you see in the movies, or maybe some of you can do it. Saya sendiri, saya tidak dapat. Saya selalu takut piring pecah. And what does the waiter do? Dia mau tukar itu. He wants to change the tablecloth. So he goes to the table and he just pulls the cloth, and he'll pull off the cloth, but all the plates will still be on the table. That's another example of inertia. He's using the inertia of the plates, because if he pulls the tablecloth fast enough, the inertia in the plates and the glasses will stop the plates from moving along with the cloth if you do it fast enough, if you do it correctly. Of course, if you do it slowly, then what you end up with is with a bunch of broken plates and glasses. So do not try at home unless you really have practiced it. So these are examples of how inertia affects us in real life. So once you understand the concept of inertia, then you can understand the concept of momentum. So momentum is basically the effect or an application of inertia, or a way for us to calculate inertia. So let me go back to the slide. So momentum. So here's a question. Okay, and you can answer in the chat. If a car and a lorry are both moving at the same velocity, so we have a car, maybe a Proton Saga, something like that, Proton Saga, or a let's say Proton Saga, and a heavy lorry. Okay, a big heavy lorry, the kind that you see carrying, maybe lots of, mungkin jenis yang angkat kelapa sawit, ataupun yang angkat tanah, ataupun yang seperti itu. Okay, if both of these vehicles are moving at the same velocity, which vehicle would be more difficult to stop? Okay, between those two. Okay, don't overthink this. Okay, the answer should be obvious, but which one is more difficult to stop? What do you think? Car or lorry? Okay, so lorry, it seems like the obvious answer is lorry, right? And of course, the lorry is more difficult to stop. Remember, we already learned just now the relationship between inertia and mass. An object that has more mass is harder to stop or harder to start moving. A lorry obviously has more mass, is heavier than a smaller car. Now, we can calculate this using momentum, or using the formula of momentum. So the definition of momentum is a product of mass and velocity. Okay? So a few things about momentum. It is a vector quantity. So remember, a vector quantity is a quantity that has direction. So momentum always has direction, so you always need to take that into account. All moving objects have momentum. So any object that is moving has momentum. Whether it's a small piece of paper that you threw in the rubbish bin, or a huge lorry that's moving at about 60 kilometers per hour. As long as this is moving, it has momentum. And the direction of momentum is always going to be the same as the direction of the velocity of an object. So a car moving this way, the momentum is also going in the same direction. So it's not like the momentum is this way and the velocity is that way. No, the momentum and the velocity, they go together in the same direction. And we can define the formula like this. Momentum, P of a moving object. So P is the symbol for momentum. Small letter P of a moving object can be calculated using the formula P equals mv. So P equals momentum, m equals mass, and v equals velocity. So very simple formula. So we can try to use it. So the question that you usually get is, you'll be asked to calculate the momentum of an object. So let's try this question here. Example question number 1. A lorry of mass 20,000, 20,000 kilograms moves with a velocity of 22 meters per second. A car of mass 2,000 kilograms moves with a velocity of 30 meters per second. So what is the momentum of the lorry and the car? So question A is, what is the momentum of the lorry and the car? And the second question is, if the lorry moves with the same velocity as the car, what is the momentum of the lorry? So let's try this question. Let's try question A first. So hopefully everyone can see the whiteboard. So let's start with question A. So in question A, there are, there we go. So in question A, we have two things that we need to calculate. We need to calculate the momentum of the car, and we need to calculate the momentum of the lorry. So let's define everything. So what is our formula? So our formula is P equals mv. So P is the momentum, m is the mass, v is the velocity. So let's try to find the velocity of the car. All right. So mass of the car. So I'll just call it m. I'll put a letter C to me that shows that's car. So mass of the car is 2,000. Why am I out of ink? This was working just now. Mass of the car is 2,000. Velocity of the car is 30. Meters per second. Mass should be 2,000 kilograms. So now we have the formula. So P equals mv. M is 2,000. V is 30. So you get a total of 6,000. What do you get? Yeah, 6,000. 6,000? No, 60,000. 60,000. And your unit would be kilogram meter a second. Very simple. Right? It's not a difficult, it's not like some of the other formulas that you learn. It's quite a simple formula. Okay? So everyone understands? Alright. So now you try. So I've already found the velocity, the momentum of the car. Okay? I want you to go ahead and try to find the momentum of the lorry. Okay, go ahead, try to find the momentum of the lorry, and then when you're done with it, go ahead and type your answer in the chat. So same formula. Just different numbers to use. Make sure you count the zeros carefully. So formula is P equals mv. So you just need to find the value of m and the value of v. Okay. So I'm seeing more answers now in the chat. By the way, how many are present right now? I have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 students present. Okay. Okay, so I've got... Okay, so... Yeah, alright. So let's check that. So, V equals mass times velocity. And then velocity of the lorry was already stated just now to be 22. 22. Sorry, so velocity mass is 20,000. Velocity is 22 meters per second. So we just times that, we get 44,000,000. So we have a... Is that correct? How many zeros are there? Did I put too many zeros or what? Yeah, that's right. I put too many zeros. Okay, there you go. Yeah. So 440,000 kilogram meter per second. All right. So yes. So very good. So you get the basic idea. Now, second question. Go on to question B. If the lorry moves with the same velocity as the car, what is the momentum of the lorry? Okay, so similar question. Go ahead and try to answer that. Okay, by now should be quite easy. So just so we are using the same lorry but a different velocity this time. So let's see. Okay, so 600,000, 600,000, 600,000. Yeah, okay, so most of you have the same answer. Let's just double check. So velocity of momentum, P, mass is 20,000. And this time the velocity says moving as fast as the car, so the car is moving at 30, and so we get a total of 600,000. And you notice that the momentum of the lorry is much higher compared to the car, right? The car just now was 2,000 times 30. So the car just now was only, how much was the car? 60,000. The car was only 60,000, and the lorry was 600,000. So you can see the relationship between, mass and momentum. Something that's heavier really creates a lot of momentum. And so it's harder to move and also harder to start. Okay, very good. Now, the idea of momentum becomes very important when we have collisions and explosions. So what is these things? So a collision is So what is a collision and what is an explosion? So basically, in terms of physics, a collision is when two objects moving in different directions, they collide. Very simple stuff, I know, but boom. All right? And the explosion is the opposite. When something is still and it explodes and it goes in different directions. So that is our definition of collision and of an explosion. Now, so the principle of conservation of momentum in collision and explosion, okay, states that the total momentum before collision is equal to the total momentum after the collision if no external force is acting on it. What does that mean? What that means is, let's say we have a collision. We have two objects moving from different directions. So one from this side and one from this side. So as we're moving, we're about to collide. This object has a certain amount of momentum, and this object has a certain amount of momentum. Okay? I hope you're understanding so far. And so if we add the amount of momentum that these two have, we have a total amount or a total number. Let's say we have 100. This is before the collision. So total from here and here is 100. After the collision, so usually what happens after a collision is they go in opposite directions. Now, after the collision, they're going in opposite directions. If we were to add the momentum, because it's still moving, it still has momentum. If we were to add the momentum from here and from here, the total should still be the same. The total momentum should still be the same. Why? Because we are conserving, we are keeping the amount of we are keeping the same amount of momentum before and after the collision. Okay? Maybe it will be easier to understand when you see the formula. So this is how the formula looks. So U, remember U is initial velocity. We've learned that before. So mass times initial velocity of first object plus mass times initial velocity of second object equals mass times velocity of final mass times velocity 1 plus mass times velocity 2. This is before the collision or before the explosion, and this is after the collision or after the explosion. Okay, so to be able to really understand it, you really need to see an example. So let's try an example here. A car of mass 600 kilometers moving at 40 meters per second collides with a car of B 800 kilograms moving at 20 meters per second in the same direction. Okay, so let's look at our information here. So A we have 600 kilograms and 40 meters per second. B is 800 kilograms and 20 meters per second. Now, very important. The question says same direction. Meaning to say both are positive. Let me repeat that. Since they're going in the same direction, both numbers are positive. If they are going in opposite directions, then one will be negative. Why? Because momentum is a vector quantity. Remember, if one is going this way and one is going this way, okay, then usually going to the right I'm not sure which side is right on the camera, but right is the positive direction, left is the negative direction. One will be positive and one will be negative. So you have to take that into consideration when you are calculating. Now in this question, both are moving in the same direction, so they're both going to be positive, but sometimes they are moving in different directions. So just keep that in mind. So car A is moving is 600 kilometers, 600 kilograms and 40 meters per second, and 800 kilograms and 20 meters per second. And then this is before the collision. After the collision, it says that B is moving at 30. Okay, so B has increased from 20 to 30. Now what it's asking is, what about A? How fast is A moving? So that's what the question is asking so far. So what formula do we use? Well, we know the formula, we've learned it. All right, we have mass 1. Let's use mass A. Let's use mass A. I'm going to buy some new marker pens tomorrow, hopefully. All right, anyway. So mass U1, so initial velocity plus, let me write it down a little bit clearer. Equals the momentum after the collision. So I'm gonna let you go ahead and try to solve the question first. Go ahead and try to solve the question, and then we'll discuss the answer, and then I'll show you the solution. Okay, I think it's better to let you try first. So go ahead and try, and then when you've managed to try, then you can go ahead and type your answers in the chat. So in this case, both are positive. So if you're not sure, make sure you write down all the information out clearly ahead of time before you put all the values into the formula, just like I usually recommend people to do. So the formula is already written out. So all you need to do is to put the correct information into the correct place in the formula. Let me just try to make sure everyone sees it clearly. So basically, the law of conservation of momentum is basically saying before the collision and after the collision, you still have the same total amount of momentum. And so you just need to find. So if you know the total amount on one side, then you should know the total amount on the other side. Kalau kamu ada apa-apa jawapan, biarpun kamu rasa salah, tulis saja. Nanti kita boleh cek juga sama-sama. Salah tu belakang kira tu. But the important thing is that you try. Because otherwise, if you don't try, you won't be able to get the correct answers. Okay, so let's see what it would look like if we put it in the formula. So we have, so mass A is 600. So 640 plus 820. So this is the first part of the equation. Equals A is the same, 600. We don't know what is the speed, so let's call this X. And 800. And the final speed is 30. Okay? Alright. Coba kira, what is the final speed of, what is the final speed of vehicle A? Yeah, I think by now sudah ka natulis macam tu, you should be able to write it out clearly. Okay, someone said 26.6. Any other answers? Takkan satu orang saja ada cuba menjawab. Okay, 26.6. Ada yang tulis 26.7. Be careful bila kamu buat bundaran ah. Always remember apa peraturan untuk melakukan bundaran. Rounding off. Alright, I'll give you 1 more minute to try and answer. Bagaimana yang lain-lain? Boleh yang lain-lain cuba bagi jawapan, kongsi jawapan. Okay, so we'll do the calculations. Alright, so we get a total of 40,000. Alright, and so, yeah, so 40,000. So 800 times 30 equals 24,000. And this, which leaves 16,000. So 16,000 equals 600x. X equals, sorry, let me just move that up so that they can see that. Okay, so 16,000 equals 600x. X equals 16,000 divided by 600, and you get 2.666666, but sorry, 26.666666, but we just round it off to 2.67, or even you can 2.7 pun boleh, depending on how accurate you want it to be. So that will be your final answer. Okay? Alright, let's try another question. So this time, it's an explosion instead of a collision. But the idea, the formula is still the same. So see if you can read the question and get the correct answers. Oh no, what happened? Why did it disconnect? What happened to my camera? Okay, there we go. Okay, I don't know what happened there. Alright. So, let's go ahead with question 3. Go ahead with question 3 and try to find the answer. What is the recoil velocity? So, now we're talking about the velocity of the pistol. Okay? Recoil. Recoil is basically when you shoot a pistol, the pistol will move backwards. That's what we call recoil. I know at least one of you knows the word recoil. Okay, so go ahead and try to calculate that. The same formula. So let me just write a few things down. So, rifle or pistol, whatever. Okay, so rifle or pistol is 2.5 kilograms. That's the mass. And the bullet, yeah. Okay, I'm really running out of ink here. Bullet is 10 grams and speed of 250 meters after that's an important word there, after shooting. So here's a hint. After shooting, it's moving at 250 meters per second. Before shooting, what was the speed? And that should help you. That should help you to figure out at least some of the numbers. In fact, what speed was everything moving at before he shot or before he shoot? If you know the answer of that, then there'll be a hint on what the total momentum should be on one side. Actually, on both sides. All right, let me type out part of the equation here. So rifle is 2.4 kilograms. Bullet is 0.001, was it? So you have to change the grams into kilograms first. 0.01 kilograms. That's right. And the speed after explosion is 200 meters per second. After explosion. Okay, so after he shoots. So meaning to say, we're using the same formula. M. So mass of the rifle, momentum of the rifle combined with the momentum of the bullet should be the same as the momentum of the rifle and the momentum of the bullet after he shoots. All right. So what is the initial velocity of the pistol and initial velocity of the bullet before shooting? If you read the question carefully, before shooting, kalau kau belum timbak berpelaju itu, peluru bergerak. Zero, right? Zero. So, since the initial velocity on both sides is zero, then you'll just put zero for everything. So, zero equals... And now we have the final velocity plus... Okay, we have the velocity of the bullet. So bullet is 0.01. Velocity is 205. So 200 and... Alright, can you continue from there? Boleh kamu teruskan dari sana. The one that we need to find is the velocity. This final velocity. We need to find the velocity of the rifle. Boleh kamu teruskan dari sana? Boleh cuba? Go ahead and try. So the mass of the rifle is 2.5. Velocity is unknown. Momentum of the bullet we know is going to be .5. Okay, from there it's very easy. So what's the final value of the velocity of the pistol? Okay, how about the rest? How about the rest of you? Do the rest of you have an answer to give? So for the rest of you, here's the clue. Since the both objects are moving in different directions, there will be a negative somewhere. The question is, where is the negative? Hey, now what's wrong with my camera again? Why is my camera not working? Okay, let me just check again. Where is what happened to my camera? Okay, let me just... Something's wrong with my camera. Just give me a minute. Okay, there we go. Okay, so let's check the answers. So the velocity of the pistol should be... You end up with -1. So if I write out the whole thing... Just give me a moment there. Why is it not wiping off? So if we look at the whole thing, so remember this is still 0. So if we move it to one side, it'll be -2.5 equals 2.5. So V must equal -1, which makes sense, yeah? The bullet is going one direction and the pistol is going in the opposite direction. All right. Okay, so I've been speaking for an hour, so I think that's enough talking from me for today. Where was I? Okay, so I'm going to I'll dismiss you after this. I'll dismiss you from this Google Meet after this. I'll send you some more exercise questions to work on. If you have any questions, just feel free to ask me lah later, either through you can ask in the group chat, or you can PM me if you want to. Memang mencabar sikit lah kita punya situasi sekarang, but I want to encourage all of you, okay? Since we have to work from home and study from home at the moment, it's gonna depend a lot of your study is going to depend a lot on your own efforts, starting from now until we go back to face-to-face classes. So I hope any assignments that you get, you'll do it, you'll complete it. Even if you feel like your answers are wrong, it's okay. I don't mind wrong answers, because you can still learn from wrong answers, you know. Saya pun I wish, kalau ikut hati saya pun I wish we were able to be in class so that I can explain it any of your questions immediately. But we have to make do the best with what we do, right? Okay, so does anyone have any questions before I dismiss you for today? No, no questions from anyone. I'm sure some of you will have some questions later. All right, so if there are no more questions,